Hi everyone, I am Rajitha, working as Assistant Professor of Artificial Intelligence and Data Science Department in SNS College of Technology. Today we are diving into propositional theorem proving, a key method in artificial intelligence for logical reasoning. So, theorem proving is like teaching a computer to solve a logic puzzle. It is a method in AI where machines prove if a statement is true or false using logic. For example, if we know all humans are mortal and Socrates is human, the computer can logically conclude Socrates is mortal. This process is the backbone of automated reasoning in AI, helping them make decisions based on fact. Understanding theorem and logical foundation. So, what's a theorem? It is a statement we can prove true using logic rules. Think of axioms as the basic truth we start with, like 1 plus 1 equal to 2. Inference rules are like steps we follow to reach new conclusions. The goal is to show that a conclusion logically follows from given fact and ensuring the computer's reasoning is solid and reliable. The next is propositional logic. So, the language of reasoning. Propositional logic is the language computers use for reasoning. It deals with statements called proposition that are either true or false. For example, it is raining as a proposition. We use operators like and, or, not, and implies to connect these statements. So, if it is raining implies the ground is wet. So, we can logically connect the two to make decision. And uh, what is propositional theorem proving? Propositional theorem proving is about checking if a conclusion is valid on given fact. There are three main ways to do this. One is truth table, the second one is inference rules, and the third one is resolution method. So, truth table which check every possible scenarios, and inference rules which build conclusion step by step, and resolution which find contradiction to prove a point. Each method helps computers verify if a statement logically follow from the information provided. And uh, how it works, the table method. Let's look at truth table. They list all possible truth values for statement to check if a conclusion hold. For example, if it is raining, the ground is wet, and it is raining, the truth table shows that the ground is wet is always true when the premises are true. It is thorough but can get slow with lots of statement because the table grows huge. And the inference rules. So, inference rules are like logic recipes. For example, modus ponens says if P then Q is true and P is true, then P must be true. Another rule, modus tollens, works backward. So if Q is false, then P must be false. These rules help computers build new truth step by step, ensuring every conclusion is logically sound. So the next is the resolution method, automated theorem proving. The resolution method is a smart way to automate theorem proving. It converts statements into a standard form, negates the conclusion, and looks for contradiction. For example, if we have P or Q and not P, resolution cancels out P and proves Q. This method is fast and widely used in AI to automate logical reasoning. And the real world applications in AI. Proportional theorem proving powers many AI systems. It is used in automated reasoning for things like self-driving car, in expert system for medical diagnosis or financial planning, and in knowledge-based agents that manage huge database. Even programming language like Prolog rely on it to solve problem logically. And the summary is, to wrap up, proportional theorem proving is how AI verify truth using logic. We use truth table, inference rules, and resolution to make this happen, forming the foundation of intelligent system. Now try this. Given if it rains, the ground is wet, and if it raining, can you prove the ground is wet? So use modest ponens. It is a straightforward. Okay. Thank you for listening. And this is the mind map for proportional logic in AI. Thank you.